Hi James, I'm going to go ahead and do the graph for problem 17, or the graph part of what we did. I'm first going to graph the entire hyperbola, and then I'm going to just restrict our range, or our range setting, so that we only get the part that they asked for. So anyway, let's go ahead and set things up that we need to do first. We go into mode, and we want to be in parametric mode. So we'll do that. Now, whether or not we want to be in connected or dot mode will sort of depend, but in our case, actually, it's going to turn out that we're probably not going to want to be in dot mode, but I'll try and show you both things as I move along. So since we've gone ahead and set that, we'll go ahead and go to our and enter our equations. The first one was secant of t, which is, of course, 1 over cosine of t. And the second one was y equals tangent of t. So we'll put that one there. And now we just need to figure out what we're going to do for our window. As you see, it goes between, it's set now to go between 0 and 2 pi, which will draw the entire hyperbola. So why don't we just sort of keep it that way for now? That's not too bad. I'll go ahead and actually write this in so you'll see that that's what it is. Okay, and as far as how fast we wanted to draw it, I found that 0.05, I did this before, seemed to work out to be about right. Okay, so how long do we want our x-axis to be? It looks like about, why don't we make it -4 to +4? And for the y-axis, we'll do the same thing. We'll go -4 to +4. Alright, so why don't we go ahead and graph it out and see what happens. And remember, this is a parametric equation, so it's going to be drawn in the direction, it'll have some directionality in how it's drawn. So as it's being drawn, you'll see the direction in which it works in, or in which it's drawn out. So we'll go ahead and start. Okay, so that's the entire parabola. Now the part we only wanted was between here and about up there somewhere, from 0 to pi/4. I've actually, t in our case goes from 0 to 2 pi, which is much longer, so we get the entire hyperbola. These parts here are actually not part of the graph. These are just the asymptotes, and the reason these show up is because we weren't in dot mode. So why don't we go put it in dot mode and just see how that'll make a difference on it. So we'll go back to mode, and we'll put it in dot mode and go ahead and run it again. And you'll see there we just get the hyperbola itself without the without showing the asymptotes. Okay, well, we can either keep it in dot mode or not. Why don't we go back and keep it in connected mode? In this case, it really doesn't matter, but we'll go ahead and do that. We'll go ahead and put it back in connected mode. And this time we're going to restrict our window to the range we were asked to do it for. I did it between 0 and 2 pi here, but what I'm going to change that to now is just have it to go between 0 and pi/4, which is the range that they asked for. So we'll go pi divided by 4. And when we graph this, you'll see that we just get that little part of it, which corresponds to the same graph that we drew by hand as we were working out problem 17 in the pencast. But so that sort of shows you the graph of that portion of the hyperbola as it's being drawn from t equals 0 to t equals pi/4, and nothing beyond that. So I'll go ahead and take a screenshot of this. And this was problem 17. Okay, that's it for now.